So a couple people asked about proving these identities with combinations. So if I have n plus 1 choose 2, my goal is to make that into n choose 2 plus n. So I'll start by just using the definition, n plus 1 factorial, n plus 1 minus 2 factorial, times 2 factorial. Then I'll break that down to being n plus 1 factorial over n minus 1 factorial times 2 factorial. Now, if I think about n plus 1 factorial, that's really n plus 1 times n minus 1 factorial. And one reason why I did that is because then I can just cancel out the n minus 1 factorials. So it simplified what is left over. So I have n plus 1 times n over 2 factorial. We've removed basically everything we can, and now we want to make this into n choose 2 plus n itself. So I need to introduce a new factor on the bottom. I want it to say n choose 2. And so I need to have an n minus 2 factorial. Well, if I multiply the bottom by something, I need to multiply the top by the same thing. N minus 2 factorial there. Okay, so then we're very close now to having an n choose 2. The only thing that's really missing from an n choose 2 is we need an n minus 1 to be right here. We need there to be an n minus 1 right there. And so this is a little bit of a trick, but you can take your n plus 1 and write that as n. I need an n. What do I need? I need an n minus 1 on there. So I have n minus 1 plus 2, because that's equivalent to n plus 1. And the reason I'm going to break it down like that is I can collect my terms then in the desired form. So I have here, I'm going to take this first piece and multiply it by everything else. So I have n minus 1, n minus 2 factorial. The denominator is 2 factorial times n minus 2 factorial. And then I'm going to take the second piece, 2, and go plus 2 times n minus 2 factorial over 2 factorial n minus 2 factorial. And there you go. This numerator here on the left side, this is all really equal to n factorial. Over here on the right side, 2 cancels with 2, and n minus 2 factorial cancels with n minus 2. So what we have just achieved is that the first chunk is n choose 2, and the second chunk is just n. So we proved the statement.